So, welcome to my YouTube channel. My name is Michael. So today I'm going to be doing all the breakdown that is required, everything that you're supposed to know about this servicing or overhauling of 280 kilowatt compressor electric motor. And then this is a practical aspect of this class. So we picked up this particular said electric motor from one of our clients to come and do servicing and overhauling. So actually we went for an inspection to inspect the job at first. So we did sort of a visual inspection because we had to know and see how we are going to execute the job before we can actually move to the site. So we went for visual inspection. So I'm going to be telling you everything you need to do to perform such task. And mind you, you have to come with your pen and writing material so that you can jot some things, because not everything that contains in this class. So some things I may be saying it based on reflex actions. So moving on here. So this is the 50 kilowatt electric motor here. This is it. So this is what we know about 2 kilowatts. So another name for servicing is also called overhauling. So that's just it. So moving on. So this is the scope of the work. So the job entails that we should do general servicing of the stator. Then we should change or service the terminal block. Then we also should changing of the cable lead, changing of the terminal nut. So that's what the job is. So in this compressor now we have both the stator and the compressor himself. So we are to do the electrical part. There are two parts, the mechanical part and the electric part, and me I specialize in that of electrical part. So that's my own aspect of this job here. So fault defect on the electric motor include coil with debris, defective cable lead, defective thread to the terminal block, defective nut to the terminal block. Fault findings utilizes a logic technique to analyze symptoms, identify likely causes, and may involve electrical measurement to locate fault or fault component. So as I said before, if you are writing, we have like 4 types of inspection. We have the visual inspection, we have the periodic inspection, we have a detailed inspections. So also the period, you can also likely to call it frequency inspection. So this work we actually used every of this inspection because it was detailed to carry out this job. And also if you check here now, if you come with me to the next slide, you check the read carefully. Servicing, reassembling and painting stage. This includes washing the stator and other part of hydro cleaner, excess varnish, baking, replacement of cable lead, replacement of terminal nut, servicing of terminal thread, reassembling and painting. So I'm going to be explaining some keywords here. So looking at this, if you look at this picture here that I use, this is the stator. You can see it's just empty. But inside this stator I have what they call electromagnetic coil. That's magnetic induction. That's the principle at which they work. So it is connected both the rotor and the stator. The stator is also known as the stationary part because they don't move, while the rotor is called the rotating part, or is a rotating part because you can see they move. That's when they are already in operation anyways. So in this place now, when servicing this stator now, what we need is what? You need hydro cleaner. Hydro cleaner is what you will get in your workshop. Sorry, you can get it in any market at all. You can go to chemical, where they say chemical, you can actually get hydro cleaner. So then excess varnish, you require varnish to do this job, and that's one we normally see here is radioxide. You also need a radioxide to perform such operation. Then in situation where you couldn't get hydro cleaner, you can actually get fuel, that's PMS. You can get fuel to do it in the replacement. In this our work, there's always alternative to almost everything you want to do. There's always alternative. Then you can actually look for the varnish. The varnish, you get it in any of your shops that they say electrical, so I just ask them for varnish, or where you can, or where they say paint as well, you can actually buy varnish there. Either you buy SS varnish or you buy Euro varnish. That's Euro varnish. Then after then you subject it to baking. But before baking it, you allowed the varnish that will varnish the motor to drip. So once it drip for some maybe 20-minute dripping, you now put it inside your baking oven. So that oven now is like, some oven is electrical, some uses gas, so it depends on the one you make use of. But the situation where you cannot afford oven, or you don't have access to oven of baking it, you can actually use halogen bulb, specifically like 1000 volt of halogen bulbs can do the miracle. But in this particular 280 kilowatt, is not just one halogen bulbs. You can use like, you can connect 4, 2 in one side, 2 the other side, so that the impact will meet the standard. You can actually use that one. Then you will now find other ones to use, which I'm going to explain later, like that of the replacement of cable lead, the replacement of terminal node, and servicing of terminal thread. Then reassembling and the painting. Let me talk briefly on the painting. This one here, this painting aspect here. So I'm going to talk on this painting now. Why do I have to talk about painting? When painting an electric motor, if you have a yellow paint and the same motor they brought to your workshop or for you to work on is red, you must paint that red that you came with, because that is the standard. So most times in the facility or in the vessel they use color code, so you don't just mix the color except the client asks you to do so before you can actually do what, change the color. But in absence of that, you must use the same color that the electric motor or the device came with, or the alternator, as case may be. So this is the task that we did in performing such task. So these are the tasks. First, we did mega reading. Mega reading, preferably you can use fluke. Fluke is for now, for us is the best to use it. There's other mega testing or mega reading device that you can use, but use fluke. So this mega reading, why do you have to do mega reading? The major reason is that so that you can know whether this particular motor is grounding or not. Or you check their cross face, you check face to face, you check. Some mega reading can actually help you to know the winding resistance of it. So, but this time around, we not really check the winding resistance because we are just here to service, because we are not the one that rewind the motor. So if you are the one that did the rewinding, I check the resistance to ensure that it is in line, that no face is more than the other. So that's why you check the winding resistance. And also you have to do this mega reading because some clients may not really know that their motor is not burnt, or some will know that the thing is burnt and they will pay for servicing. And once you take it out of the facility without checking all those things, the you may run out of loss or you may run into trouble. So it's always advisable check everything there before taking it out of the facility. Also, before the dismantling of the number 2, let me quickly talk on this number 3, that is this number 3 here. This number 3, that is collection of winding data. Winding data is all the information in the nameplate. That's when you collect the serial number of the electric motor, display the right serial number, and also where you can see the kilowatt of the motor. Some motor comes in kilowatt, some come in horsepower, some come in kVA. All of them are convertible, so you can convert one to another, which I'm going to do video on how you can convert that. And also from the specification you determine the voltage, you determine the current. So if you don't know those things in the nameplate, after doing the work you may not really get exact the same thing that the OEM of the equipment has gotten. OEM, that's the original manufacturers. So it's always advisable that you get all the information from the nameplate. And as well, if the motor is already old or the equipment is already old, the nameplate must have fallen off. So you will ask for your client to send you the specification of the motor, so that it will enable you to know what you have done during testing stage. And then for this scope of work, as I said earlier, we have to replace the terminal nut, the servicing of the stator, and other part, the washing, braking, reassembling and coupling. So let me talk briefly on dismantling again. Before dismantling any device, make sure that you look carefully and see how it is. How do you do that? Because our brain thinks a lot. So what we do to help you in this regard is you have to get a permanent marker. So when you get a permanent marker and masking tape, it's also called the insulation tape, as some people, that's the right word here, is insulation tape. So insulation tape is also called that masking tape. So you don't use any other tape to mark it. You will label it, or you will punch. You understand? You will punch it to say, okay, if I punched A and B, if I want to connect it here, this is it. So all those things just give you mark. You must be able to give it mark. You can use anything to give mark, like that permanent marker, the punch, or anything that can give you visible mark that is permanent, that won't clean. That's what you use to do marking. If not, when you want to copy it back, it will give you a big challenge. You may just make the whole thing up, and in the process you may get everything damaged or burnt the work you have done. So that's why you have to do what? Marking. Then the excess vanishing or assembly. When varnished motor, you have to do it carefully so that you not vanish the side you are not to vanish. So I will show you the side you're supposed to vanish in my next slide. Then the baking. When baking takes a long time. You don't bake less than 24 hours in such a 280 kilowatt and others. You must bake above 24 hours. You can bake for 8 hours, you can bake for 3 days, you can bake as long as the client still wants you to bake, but you cannot bake less than 24 hours. So as you are baking it, you'll be checking the mega reading, you'll be checking to know how the thing is going in case the reading is coming up or dropping. So that will determine what you will do. Then the testing is what you will do before you couple. You will do what they call pre-test. So you have to do pre-test before you now go ahead and paint. The pre-test will enhance you to check, okay, this thing that I've done is okay or not. So most times, if it's all those small electric motor, it's always advisable, if you are the one that rewind the motor, it's always advisable before you go ahead to varnish your motor, do the test first. So the test will enhance you to know that okay, this job that I'm doing now has reached the stage of vanishing, because if it vanishes before testing, if you want to correct it to be very difficult and you may end up damaging your work. So if you do pre-test, maybe the motor is jerking or the motor is not running properly or is taking low amps or high amps, that will enable you to do what? That will enable you to do the correction. So that's the testing for you. Then we now talk about that of the painting stage. The painting stage, after you have tested the whole things, you now go ahead and do your painting. I've explained painting earlier on. Then for this our job now, we are meant to do the installation of the motor back to the main engine, then we commission. To my next slide here, we have the collection of the winding data, that's the face-to-face. So this is the fluke that I'm talking about. This is the fluke that you use. So that's the fluke device that you use. Inside this fluke here, this is what they call the probe. This one is the probe here. So this is the battery, understand? This one is what you use to test. So you plug one of the probe here. You see the one that you're supposed to plug here, plug one here. Then from there you now take your readings. So this is UT8. When I checked it, UT8 was giving me 977 mega ohms. Sometimes the mega ohms or kilo ohms, or it can be mega ohm, it can be kilo ohms. As case may be, let me check whether I can draw the kilo ohms like this. So sometimes can be in kilo ohms or mega ohms. So two of them is actually good. But if you measure a motor, it's giving like 4 ohms, 4 mega ohms, 8 mega ohms, 40 mega ohms, 50 mega ohms, 60 mega ohms. The motor is not actually acting, but it's just that it's down. So it will be subjected to further what? To be subjected to further baking and servicing in order to boost the mega reading. So most times if you just check your motor and you find out that the thing is low, what you do is that you subject it to what? To baking. Or you take it to any technician. If something you cannot do by yourself, you do what? You heat it up and then you check the mega reading again, it will come up. So that's what we do in this stage. So here you can act with this fluke or mega here, you can actually check face to earth, face to earth, that's V1 to earth, V1 to earth, W1 to earth. You can also check across face, that's U1 to V1, V1 to W1, W1 to U1. So this how you check the face across face. Face to face is just U1 to U2, V1 to V2, W1 to W2. That's how you check what? Face to face. Then when you check face to face, it's always going to be giving you 0. Like U1 to U2 will also give you 0, because if you don't give you 0, that means it's wrong line. It's looping. The line is actually what? Looping. So it must give you what? 0. Then sometimes these flukes, some of them can actually help you to do to check the resistance. But a situation where fluke cannot give you the resistance, you can use the clamp meter to check for the resistance. So let me move on to the next slide. So this is the motor now. This is how we make this motor now. We made it from this point. We made this motor from this point here. Sorry. So okay. Sorry. We checked it here already. So after I made the motor, we disconnected it. This is the line here. So this is the line. This line now we have line 1, line 2 and line 3. Why did they use this what they call color code? This is blue, this is what yellow, and this is what red. So that's the color code. This color code now is RYB, that's red, yellow, blue. So you can check before dismantling this. It's always advisable that you use your permanent marker and the installation tape to label it so that you will not mix things up. So always check how you made these things and properly label it. Once you label it, it will enhance you to do what? To know how you will connect it back. So don't rush your work. Be very calculative. Be very calculative in doing this. So that's one of the things you ought to do in performing such operations. So this one now is the lead. We are asked to change this lead here. This lead that you are seeing here. We are asked to change it. We are asked to change this lead. So we have to change this lead here. Why do we have to change it? What's wrong with lead? The lead it was like kind of a peeling, and if they connect it when it's running, it will be dropping something like particles, so it's old. And if you check here also, this is the thread, that's the thread, terminal thread that we're asked to service. So this terminal thread now is bad. If you check this place that I just marked right now, this is something that is rust inside already. So you see something like rust already inside it. So that's why we change it. See something like rust there. And then this is the thread, the knot that they say we should change. This is the knot that we have to change. Sorry, move to the next slide. Then okay, after that, this is the next slide now. We will now do what? We will now check. We have already serviced the motor. This is where I'm going to show you where you were supposed to use your varnish, your radial side. So this place now coming. So this is where you will use your what? Your radial side. You paint this place. I am checking. I'm telling you now. This is where you paint your radial side. You paint your radial side here. Then in this place now, why we painted the radial side is because of we will not necessarily need to paint this one radial side. We just needed to paint it so that it will not do what? It will not cause rust. Radial side is just anti-rust. So this side now, that's where you paint your radial side. Then your varnish. This is where you varnish the motor. You varnish it here, plus you varnish it. So this is where you focus in varnishing, just the core that you varnish. Why do you varnish it? You varnish it to make it stronger, and then to also help in the service, front of the servicing processes. And then this place now, you can see my team and I trying to connect the lead. So this is the lead. These are the wire that came from this lead. That's the W1, the W2, the U1, the U2, the V1 and the V2, then the neutral, and then so that's why we are doing what? We are trying to connect this line here to this terminal block. This is terminal block. So anytime here terminal block, this is the terminal block here. So this side is the terminal block. So I've always said that engineering is not something you'll be doing and be quarreling. You don't need to quarrel anybody. It's something that you must do in unity and as a team. Because once there's a quarrel, you may not bring out your best in telling the other one idea. So you must leave your differences when performing such tasks. Because any mistake you make to cost your company a huge. So it's not something you start carrying grudges to one another. So you see, it's a teamwork. It's not something that one person say, "You will leave it, I will do it all by myself." It's not so. So it's something that is done in unity. Moving on to the next slide. So we have finished working at the electric motor in our workshop. We now brought it back to the facility. This place here that we are looking at is this place here, these are the people that we brought the equipment back. You can check the men here. They are trying to check the mega reading of what we have done. Because if the mega reading is done or is not giving them what they want, this job will not proceed. So they have checked it. You can see this particular person here. This one here is trying to do what? He's trying to record the thing from his phone. Why this guy is the one doing the reading himself, the one doing the reading. So all those things engineering doesn't like. Every stage that you do not get it correct, it will tell you that this one is not correct. So you don't pass any stage and enter another one. You don't jump. So every stage matters. Then after they have checked it, we started to do installation. We are now checking, calculating how we can use this forklift here to install this electric motor. So every time you will use forklift. While we are using forklift is there's no space where we can hang chain block or belt, because you actually need chain block and belt. That's part of the thing we use for execution of this job. So this is the F-frame. This F-frame couldn't carry the electric motor. It couldn't give us the desired result that we wanted. So we needed to get source for this forklift to enhance us to able to fix these things. So these are my team that we are trying to install this, putting it together on the best approach to do this work. Then this is also my team. You can see I told you engineering work is not something you do and start quarreling, sharing of idea. All of us, we are sharing idea. Okay, this is what we're supposed to do. This is how we're supposed to hang the chain block. So this is the chain block, and this is the forklift. This was supposed to be the F-frame, but we did not really make use of it like that compared to the way we made use of forklift, because F-frame was not really carrying these things very well. And doing this job, you need to be extremely careful. Any mistake you make will damage things. So you have to be carefully do this. Then we have already positioned it. This is the rotor now. This one is the rotor, and this is the stator. This one is the stator here. Everything here like this is the stator, and this inside here that is open, that's the terminal block section. So we are checking how we can slot this inside the rotor. This rotor here did not come out with the stator, but some will come out together. But the way they design this equipment here, the rotor is always permanent here. It's fixed, don't need to come out. It's only the rotor that will come. It's only the stator that comes out here. So if you check very well, you can see that we are carefully putting it, because if mistakenly this rotor jam the stator and they affect the coil, the whole work is damaged. So it's something that we must done carefully well. To do this, to rewind this motor will not cost you less than, if it's in Nigeria you are watching, to not cost you less than 20 million naira to rewind this motor. To not cost less than 20 million. So you can imagine you damage a work of 20 million naira to do this. So you will know how much that will cost you. So you need to be very, very careful in doing this job. It's not something you will hurry and come and claiming expert. So moving on now, we have finished installing the motor here. So this is how we made the motor. We install it back like this. So this is where we have installed this motor back. We have installed it back. You can see we have painted it. It's beautiful. It's just where we made the motor, we left it there. So you see that everything is so beautiful. It was very dirty before, but when we painted it, serviced it, it came back to original. So okay, we have finished installation. This is the testing stage now. Testing stages and final stages. This is the ammeter or clamp meter. So this is the clamp meter that we put on this line. This is panel. So this thing is inside the panel now that they are using to check. The electric motor is already on. So they are checking the amps to know what the arms, whether we have tampered it from the OEM. So that's why they are checking it that it meets the original manufacturers. So they have checked it, and as of the time they are checking it, everything was okay. So you check it first on no load before you will load this thing. So this one is just the system that can use to test everything. When we did the motor first time, we found that one of the sensors will not connect it very well. So we opened it again to check. So this thing enabled us to know that some sensors are not good or will not terminate the sensor very well. So these are the information that will be displaying this display unit. So this display unit will enhance you to know everything that you have done and what the reading is, and also where you can power the equipment from. That's the work of the display unit. So to the next one. So in conclusion now, every stage are very important. So that in this aspect, there is no stage that is more important than the others. Every stage that you are doing this work is very, very important. So you must be carefully and do the job, because it's not something that you say, oh, I'll jump stage 1, I'll jump this, just like you are solving mathematics. Those of you that when you're in the school, you're solving particular maths now, you now say, okay, let me collect this item, you now use this one and put this one and put this one and put that one. By the time you start summing up, you know that you have missed it. Either you go back from the beginning or you have failed the thing. So that's the stage. So there's no stages that is more important than the others. Every stage plays a crucial role. And also you must have the ability to think very fast. You must think very, very fast, because if you don't think very fast, you will damage things. And sometimes when doing such work, you don't have plan based on, okay, this one now is work procedure, that this I'm going to do. Because you can be doing this job now, you now find out that this one I'm doing is not, you are not making use of it. So you have to think very, very fast. You have to look around and find improvise how you can provide as an alternative to carry out the work. Because the thing happened to me when I went for an inspection. Everything I planned to do and all the job procedure that I was supposed to follow up, and I find out that there are some things that was lacking. So I have to think very fast on how to execute such job. Then, as I said before, make sure that you get this permanent marker, or this permanent marker. Let me use a clear one. This permanent marker here, you must be able to get this permanent marker. This permanent marker and installation tape. This is what will help you to help you to do your labeling very, very well. So anytime you are going to site, always go with this. And then every stage is very, very important, as I said earlier before now. It's very, very important. So if you check this, ask question. If there is any stage that is not clear to you, ask question. Ask. Don't come and say, oh, I know this thing, so I know that one. So asking questions, sometimes if you go to any facility, don't just start work and start losing. Try to ask questions, communicate with the people there, communicate with them, ask them, this particular thing, I notice, how does this thing work, how does this one, how do people lose it before now? It doesn't make you a weak person, it doesn't make you that you don't know what you are doing. It's just that you are adding more information and how you can execute the job. Don't just start, always ask questions. Just like me coming to your house now, I'll just start entering from room to room, I may just jump inside the well without knowing. So, but if you guide me, you tell me, okay, step leg here, don't put leg here, this is your house. So that's how this thing is. Those guys you meet there, they are very competent, that will be doing the job before now. So you that is going to as an expert trade or a technician, don't just go there and start doing your work because you have done it in A, so you can do it in B. Yes, you can, but always ask questions. They will guide you properly on how you will do it. And then lastly, remember that it's a copyright. Everything you do is a copyright. You're not the one that manufactured the equipment, and you must meet the standard of OEM, that's original manufacturers. So you must meet their standard. It's not because you meet, let me say, you test electric motor now that is 62 amps, then when testing it you are getting 32, the total amps now 32 or 40, that means it's low, or you're having 70 or 89 is high, then you say it's okay. When you leave it like that, the thing will just get burnt because it not meet to the OEM standard. So remember, it's a copyright. Anything you are doing, you must leave it according to the original manufacturer of that equipment. So thank you for watching. If you like, subscribe to my YouTube video. Please subscribe, like and share, so that you get more tips on engineering and all that information that is very, very educative to your well-being. My course is majorly practical courses. So thank you so much, and do have a wonderful day in whatever country that you are watching from.